Let's continue with the 1998 test, multiple choice, section 1, number 6. If x squared plus xy is equal to 10, then when x equals 2, dy over dx is equal to. Now, if we want to find the derivative of this equation, we have to realize what we're dealing with. First off, this function is defined implicitly because we have the x and y mixed in together. We don't have y is equal to, and everything is separated with the x's on the right hand side. So this is implicit differentiation, so we have to remember the steps for that. And also, we have to be careful here. Once we find the derivative involving two variables that are being multiplied together, we have to remember to apply product rule for derivatives. So first off, with implicit differentiation, the steps that we take there is every time we're trying to evaluate a derivative involving a variable involving y, we have to find the derivative for that y term, and then we have to attach a dy over dx. So x squared will become 2x. And then here, x times y, we have to go through product rule, which is f prime g plus f g prime. So f prime, the derivative for x is 1. The derivative for x times y, sorry, f prime, the derivative for x is 1 times y plus f times g prime. So now when we get to the derivative for y, we have to say that's dy over dx. And this is what, and then the other side of the equation, this is where students forget to take the derivative for a constant. And so 10 does not stay 10. 10 goes to a 0. So when we start plugging things in, we're trying to find dy over dx. So if we plug 2 in for x, we get 2 times 2. We have a value for x that we can plug in. But for y, we don't have that value given to us. Okay? And if we're missing a y value and we're missing dy dx, then we can't solve for dy dx. We still need to find this y value. So we have to look, how can we find this y value? Well, we have our equation. We have our x value. So maybe if we plug 2 in for x, we can solve for y. So we have to take this additional step because we're missing this information from the problem. So plug 2 in for x, we get 2 squared, which is 4. 4 plus 2 times y is equal to 10. So we just solve for y. We get 2y is equal to 6. Y is equal to 3. Now we have the y value we can plug into our derivative equation. And now the only variable that's missing is dy dx. We can solve. 4 plus 3 is 7. Subtract 7, divide by 2, and we get negative 7 over 2. Okay. Find the definite integral of x squared minus 1 over x for our bounds from 1 to e. So anytime you see a definite or indefinite integral problem, first thing you want to try is, can you expand simply by resorting to power rule? So we can expand this. X squared over x minus 1 over x. I get rid of the parentheses. And I can also get rid of one of these fractions here. So x squared over x reduces to be x. 1 over x, I could write this as x to the negative 1. But if we remember x to the negative 1, the integral will produce, if we go through power rule, it will produce something that is undefined because we'll get x to the 0 over 0. So we have a special rule for 1 over x, which is natural log rule. So once we're here, we can just apply the rule, and these are both our standalone problems that we can separated by minus, so we can find the rule separately. X becomes x squared over 2 using power rule. 1 over x becomes natural log of x. And then we just plug in our upper and lower bounds. Plug e in for x, we get e squared over 2 minus natural log of e. Minus, now we plug in the lower bound, 1/2 minus natural log of 1. And then we just simplify. E squared over 2, natural log of e becomes 1, minus 1/2, and then that goes to 0. So we simplify this down to be e squared over 2 minus 1.5, or minus 3/2, and that matches with e. Okay, number 8. Let f and g be differentiable function with the following properties. Our g of x is greater than 0 for all x. F of 0 is equal to 1. if h of x is equal to f of x times g of x and h prime is equal to just f times g prime, then f of x is equal to. Now, they've given us these two information, which we're going to have to fill in some of the missing pieces here so we can figure out how to find f of x. Okay. So if we're trying to get from h of x to h prime, notice that this f of x times g of x, these are two separate functions. So if I want to find the derivative involving two functions that are being multiplied together, I have to go through product rule. So maybe if we write out the product rule, we can begin to see some of the missing pieces and just begin to piece those together. So h prime, if we go through product rule, it's f prime g plus f g prime. However, they're telling us that h prime is only equal to f of x times g prime, which means that this portion must have just gone away. And the only way that this can go away is if this is equal to 0. So we know then that this portion of our product rule will just go away, so we know f prime of g of x equal to 0. Now from here, we can break this down even further because they tell us that g of x is greater than 0. So this could be like a 3 or 4 or 5. And if we're trying to multiply something times a value that's greater than 1 and the result is still a 0, then that means f prime must be equal to 0. That's the only combination that can work if g of x is a positive value. So we've narrowed down to the fact that f prime is equal to 0. So if f prime is equal to 0, and we know that f of 0 is equal to 1, then we know that f of x can't be equal to 0, which means that f of x must be equal to 1. Okay, this is the only one that's going to fit. F prime, g of x, e to the x, none of these will produce an f prime equal to 0. Right? And we know 0 can't be the answer because they're telling us f of 0 is equal to 1. Right? If I plug 0 into 0, I'm not going to get 1. So kind of a difficult problem because we have to go through all these different hoops to get to our solution. Okay. Number 9. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passes through the pipeline that day? So if this graph represents barrels per hour, then the portion, this area underneath this curve will represent the total number of barrels. So we can estimate the area. We know that this is going to be 24 with the height of 100, so that's 2400. And this is essentially, we can think of this as half of a rectangle, right? Each part of this curve has pretty much half of the rectangle covered. We know a rectangle is 6 times 100, which is 600. So half of that must be 300. So 300 plus 300 plus 2400 will give us 3000. So that is our rough estimate based off of what we can gather from the area underneath that curve. All right, number 10. What is the instantaneous rate of change at x equals 2 of the function f given by f of x? Now, if we want to find the instantaneous rate of change, this is essentially asking us to find the derivative. And if we find the derivative for a function that looks like this, we're going to have to go through quotient rule, which is f prime g minus fg prime all over g squared. So x squared minus 2, the derivative is 2x times g of x minus the top function, x squared minus 2, times the derivative of the bottom function, x minus 1 becomes 1, all over denominator squared. So we can distribute, combine terms, simplify. We get 2x squared minus 2x minus x squared plus 2, which reduces to be x squared minus 2x plus 2 over x minus 1 quantity squared. Now we can plug 2 into that derivative to evaluate. So 2 squared minus 4 plus 2 is 2. Denominator gives us 1, so 2 over 1 is 2. Okay, so our answer is D. Okay, number 11, if our function is a linear function between a and b, then the definite integral of f double prime is equal to, so let's get down to f double prime. Okay, we know that f of x is equal to a linear function, so I could represent this as 2x plus 3, 4x plus 5, or just in a general form, mx plus b. Now the derivative for a line, a linear function, will just be, let's say it's 3x. The derivative of 3x would just be 3, and the constant would go away. And then the second derivative of a constant would just be 0. So now they're asking us to find the definite integral of 0. Okay, what's the area under a curve that is 0? There is no area under the curve of y equals 0. So if you were to graph y equals 0, that is just going to be the x-axis. And the graph between the x-axis and the graph and the curve is not going to amount to anything. So we know the definite integral of 0 is simply going to be 0.